first in the queue, that element will be removed from the queue. Okay, so that element will be removed from the queue. So queue algorithms, NQ, DQ, queue front, queue rear, the algorithm, these 4 algorithms we discussed in our last session, and its equivalent C code also we discussed. Okay, C functions. Okay, so that also we discussed in our last session. So in today's session, first we will discuss about the C implementation, means stack and queue implementation using array. Okay, then we will discuss about the application of queue. Okay, after that we'll discuss about doubly linked list. Okay, so the other models of a linked list, circular linked list and doubly linked list. So these concepts we'll discuss in today's session. Okay, so now we already discussed about the stack, and we implemented the stack using linked list concept. Okay, so the stack can be implemented using array or linked list. We already discussed about the linked list implementation. Okay, so today we will discuss about array implementation. Okay, so array implementation, suppose if you are creating an array, you can move the index position. Okay, so we need to maintain an integer variable called top. Okay, it locates the current index position where we can insert the values. Okay, so what is the current top value? Okay, so which element we can currently access? So that index will be stored in the top variable. Okay, we can give a name to an array. Okay, suppose if we are taking this example here, we first pushed 5. Okay, then we pushed 6, then we pushed 9, and then we pushed 2. Okay, currently the top index is pointing to third index. Okay, top is pointing to third index. Okay, suppose if we are trying to pop, means this 2 will be removed and the top will be subtracted by 1. So top will be pointing to index position 2. Okay, that is, it will point to the 9 value. So that is what top. Whenever we are pushing an element, top value must be incremented by 1. So top is integer value. It holds the index of the current position. Okay, suppose if you want to push one more element, we need to increment top. So top will be pointing to the 4th index, and there we can insert a new value. Okay, suppose if we are trying to insert one more value, means the array size is not sufficient. So stack overflow error must be generated. Okay, so this is illustration of a stack using array implementation. Okay, let us check the functions, C implementation function. Okay, see here, this is push operation. Okay, so the C code for the push operation. Okay, so the push function receives one integer stack and the data to be pushed into the stack and the top pointer value. Okay, top is passed as a reference. Why means the top must be incremented. Okay, after the push operation. Okay, suppose if top value is equal to maximum index value. Okay, suppose the array size is 10, means the index value, maximum index value is a 9, because the array index in C starts from 0 to 9. Suppose if size of an array is n, the index values that we can store in an array is 0 to 9. Okay, n minus 1. So maximum index. Okay, if it is reaches the maximum index, means it is a stack overflow. Okay, and return 0. Okay, so this function returns either 0 or 1 boolean value. Okay, so if it is a success, it returns 1, otherwise it returns 0. Suppose there is no stack overflow error, we are incrementing the top by 1. Okay, so if you wish to insert a value, first we need to increase the top. Currently top is pointing to 3. Okay, it holds the index 3. So top must be incremented by 1. So top will be pointing to the 4th location. So in 4th location, we are assigning the new data. Whatever the data we are getting it in the push function, the data we are assigning in the 4th position. So push operation is success. We are returning 1. Okay, so this is what push operation. Okay, let us check the pop operation using array. See here, for pop function also we are receiving a stack and the data and top pointer. Okay, now the data pointer contains nothing because it is, we are receiving it as a reference. Whatever the data pointed by top currently, the data must be moved to this reference. Okay, and then top must be decremented by 1. Suppose if top is -1, initially the top value will be initialized to -1. Okay, if you are checking the stack, okay, first index here is a 0. First index is 0. So initially top value will be -1. So when you are inserting the first element, first we need to increment the top. So -1 plus 1. So top will be pointing to 0. So in the 0th location, we will insert the 5. Okay, so initial value of a top in array implementation is a -1. So if it is a -1, what is the meaning? Means it is not possible to take any element from the stack because stack is underflow. Okay, stack is not having any elements. So that is what the meaning. Okay. Otherwise, so whatever the current value pointed by top, that value you are storing it in data. Then decrement the top value, top equal to top minus one, and return one. See here, if it is a failure, return zero. If it is success, we are returning one. So this is pop operation. So we are going to discuss only three functions here: push, pop, and then stack top. The next function is stack top. Okay, so stack top, it is more or less equal to the pop operation. Okay, here only the top decrement operation. Okay, top equal to top minus one. Only that statement that statement is missing here because after reading the value pointed by top, we should not we should not reduce the top value. Okay, so that is what stack top. Currently, what is the value pointed by top? Okay, reading that is called as a stack top operation. Okay, see here, it is these two functions are more or less similar, except that the top equal to top minus one, all other statements are same. Okay, so these are stack implementation using arrays concept. Okay, let us take the execution of these functions. See here. So totally three functions I have created: push, pop, and stack top. All the three functions, the parameters are stack parameter, and then data parameter, and then top parameter. For stack top, no, we are not modifying the top value. We are not incrementing or decrementing the top value. So that's why here we are passing the top as a value, not as a reference. But in push and pop operation, we are incrementing the top and we are decrementing the top. So it must be modified in the calling function also. That's why we are passing this as a reference. Okay. Now in main function, we created one menu based application and all the three functions, whatever we used in the PPT. So that functions we are writing it here. Okay. Now let us check the output. First I'm inserting 100, then again I'm inserting 200, then again I'm inserting 300. Okay, now if I'm checking stack top is 300. Okay, three values I have inserted: 100, 200, and 300. Stack top value is 300 now. Okay, now let us perform pop operation. Okay, so I removed the top value, that is 300. Now if I'm checking stack top, it is 200. Okay, now again one more pop operation. Okay, now stack top is 100, only one element is there. Okay, suppose if that element also popped. Okay, now if I'm checking stack top means stack operation failed. Okay, because underflow error, stack contains nothing, so we cannot remove any element from the stack. Let us try to pop. See here, pop operation also failed because stack is empty, we cannot pop any element. Okay, totally I have created the array as a size 10. Okay, suppose if I'm trying to insert 10 elements, when I'm trying to enter the 11th element, that time I'll get stack overflow error. Okay, let us check that also. 1, 10, 1, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now I have inserted 10 elements. Okay, now I'm trying to enter 11th element. Okay, 110. See here, the operation failed, stack overflow error. Okay, because it is not possible to insert values more than the size of the stack. Okay, in linked list implementation, this option we didn't check because in linked list. So in the linked list implementation, the memory allocation is dynamic. Until we have sufficient amount of memory, it is possible to insert a number of values into the stack. Otherwise, we need to fix the size of the stack. Okay, 100 elements, 10 elements. So whenever the count reaches that 100 or 10, we must generate the stack overflow error in linked list concept, dynamic memory allocation linked list concept. Here in array, always whenever we are creating an array, we will give some size to the array. Beyond that size of the array, it is not possible to store any element. Okay, if we are trying to store means some garbage value or some program crash may happen. So in push operation, we should check whether the top reached the maximum element or not. If it is reached, means we should generate an error called stack overflow error. Okay, it is not possible to insert any further elements into the stack. The stack is already filled. That is what the meaning. Okay, now if I'm checking stack top means I'll get 100 as output. Okay, I have inserted 10, 20, 30, 40, and the last element that I inserted is 100. Okay, 100 is at the top of the stack. Okay, we can push, we can pop all the elements also. Okay, now let us perform the pop operation. So all the elements I have popped and underflow error. After removing all the elements, 10th element is the first element I inserted in the stack. That also till up to 10, I have removed all the elements from the stack. Now pop operation failed because stack contains nothing. So this is what stack implementation using arrays concept. Okay. Now here, if you're taking, I have created a stack array, integer array. Then I have declared one variable called the top. Initially, top value is -1 and data to store the data to be pushed and the data retrieved from the stack. Okay, so to store that, I have created a variable called the data and a choice for the menu operations. These are all the 4 variables that I have created in the main function. These variables, I am passing to the push, pop, and stack top operations functions. Okay, so this is stack using array implementation. Okay, and if you're checking net, you will get different kinds of programs using array also. Okay, as we already discussed, the important thing is we have to check whether it is a overflow or not. Okay, and incrementing the top and storing the data. These 2 operations are important in push function. Okay, and the same way pop means we have to check the underflow condition and decrement the top value. Okay, decrement the top variable. So these 2 functions are important. The same way stack top also, checking the underflow condition and copying the stack top value to data. This is important. Okay, so this is stack implementation using arrays concept. Okay. Now let us discuss about the array implementation of queue. Okay. Okay. So like a stack, we can implement the queue also using arrays concept. In stack, we declared a variable called top, okay, to maintain the top index of a given stack. Here in queue, we need to declare 2 variables, front and rear, okay, to point to the starting index and ending index, rear index and front index. So whenever we are adding an element, we must increment the rear, and in that place we need to store the value. Whenever we are deleting the front, we must increment the front. Okay, so this is what we will do it. If you're taking this picture, okay, initially front and rear both will be pointing to -1. And when you are inserting the first element, that is here in this case is 7. Okay, when you are inserting the 7, first rear must be incremented by 1. So -1 plus 1, 0. Okay, rear will be pointing to 0, and in that location we will store 7. Okay, suppose in a queue, if that is the first element that you are inserted, okay, then you must increment the front also. Okay, suppose if there is only one element in the array, front and rear both will be pointing to the same index location, 0th index location. Now to insert the second value, okay, that is 2. We need to increment the rear by 1. So 0 plus 1 is 1. Okay, so rear will be moved to first index and 2 will be inserted. Okay, then increment rear by 1 and insert 6. Increment rear by 1 and insert 9. Increment rear by 1 and insert 1. Now all these elements we inserted. Current rear is pointing to index 4. Okay, that is value 1. Okay, and the front is pointing to 0th index. 0th index contains 7. Okay, so q front value is 7 and q rear value is 1. So this is how the q operations in array will work. Suppose if I'm trying to remove a value, dequeue operation means, so when you're performing the dequeue operation, the front will be moved by 1. So instead of pointing to 0, now front will point to 1. Okay, front will point to index 1. Okay, that is the value 2 will be pointed by front. Okay, dequeue operation. Again, if you want to perform a dequeue means, again increment the front 2. Okay, again dequeue operation front. Again dequeue operation rear. Okay, that is front and rear will be pointing to the same index. Again, if you are performing the DQ operation, means the front will be pointing to 5 and the rear will be pointing to 1. Now, the front value is greater than rear. It means that the queue is empty. So we should reset the rear and front pointer to -1. Okay. Whenever the front is crossing rear, it means that all the elements in the queue is popped. So we need to reset the front and the rear value to -1. Okay. So this is what the array implementation procedure. Okay. In array implementation, there will be some difficulties. That is checking whether a queue is empty or not. Okay. Without count variable, it is a little bit difficult to maintain that. Okay. So for that, some alternate solutions are there. So first we will discuss the simple implementation. Okay. Then we will discuss about the complex implementations of queue. Okay. Now I hope you will no doubt in this pictorial representation of queue. Now let us move to the C code. Like stack, here also for the enqueue operation, we are passing one queue array, then data to be enqueued, and front pointer, rear pointer. We need to pass both front and rear pointer because based on the queue is empty or not. Okay, sometimes we may be in need of using front pointer and also rear pointer. Okay, first I am checking whether rear reached maximum index. So whenever we are inserting a value, we are incrementing the rear, and in that place we are inserting the value. Suppose if rear is reached maximum index, okay, rear is already reached maximum index, means the queue is full. Okay, and it is not possible to insert any further values. Okay, so if rear is maximum index and the front is 0, means queue overflow error. Else, okay, suppose if front is -1, what is the meaning? Means that is the first element we are going to insert. In such case, we need to move the front pointer to 0. That is front equal to front plus 1. We should give -1 plus 1 is 0. So directly we are assigning front equal to 0. Then increment the rear by 1 and assign the data to the queue. Okay, queue of rear equal to data. Okay, in case of failure, return 0, otherwise return 1. So this is the enqueue operation. In DQ, it is like a stack pop operation. First we are checking whether queue is empty or not. If queue is empty, queue underflow error. Otherwise, the data, okay, whatever the current value pointed by the front index, okay, in the front index, whatever the value available, that we are moving to data, then incrementing the front equal to front plus 1, okay, return 1. So this is DQ operation. On success, return 1, on failure, return 0. So these two values, we are a boolean value, 0 or 1, we are returning. Okay. Now the next is queue front and queue rear. So it is like a stack top operation without modifying the front or rear variables. Okay. What is the value pointed by front initially, and what is the value pointed by rear currently, that we need to check. Okay. So for that, the queue must contain some value. So suppose if the queue is empty, we are returning 0. Otherwise, whatever the front is pointing currently now, that we are moving to the data variable and returning 1. Okay, so this is queue front, and the same queue rear. Instead of reading the front value, here we are reading the rear value. Okay, so this is queue rear, reading the queue rear value. Okay, now let us check the execution of this implementation. Okay, so now queue array. Okay, so here we have implemented 4 functions: enqueue, DQ, queue front, and queue rear. For all the 4 functions, we are passing queue array, integer array, then data to be enqueued or dequeued, data variable we are passing, then we are passing front and rear. Okay, wherever the function, we need to modify the front variable and the rear variable. For that functions, we have to pass the front and rear as a reference. Okay, see here for queue front and queue rear, we are simply passing front and rear variables as a call by value, okay, not call by reference. So here it is passed as a value, not as a reference. Okay, for queue front and queue rear. In these functions, we will not modify the values of front and rear. That's why this is passed as a values, not as a reference. Okay, so we created a menu-based function, and in the menu-based function, we are invoking enqueue and dequeue functions, then queue front and queue rear functions. Okay, let us check the execution. Okay, now let us perform the enqueue operation. 100 I am enqueuing. Enqueue operation is success. Now if you are checking queue front also 100, and let us say queue rear. Q rear also 100. Since the Q contains only one value, both front and rear pointing to the same element. Okay, now let us perform one more value in Q operation. 200, 300, 400, 500. So totally 5 elements I have inserted. Okay, suppose now if I am checking the Q front, okay, now I am checking the Q front means B. See here, Q front is 100 and Q rear is 500. Okay, the last element that I inserted is 500. So Q, the last person standing in the queue is 500, and the first person standing in the queue is 100. Suppose if I am performing DQ, okay, 2, DQ operation is successful, okay, and 100 is removed from the queue. Okay, suppose now I am checking Q front will be pointing to the 200. Okay, because 100 I removed. Now the queue contains 200, 300, 400, and 500. Okay, totally 4 values are there in the queue. Let us perform one more pop operation. Sorry, DQ operation. 200 removed. Now Q front is 300. Okay, and the Q rear is 500. Okay, so this is what Q operation. Okay, that's it. This is Q operation, Q front and Q rear, NQ, DQ operations. Okay. Any doubt so far? If you have any doubts, please post it here. I'll wait for 2 minutes, then we'll proceed. Yeah, correct, Rahul. Your question is after adding 10 elements and deleting, can we still add? So after adding the 10 elements, the rear and front will be pointing to the last index. So whenever after popping means after you inserted all the 10 elements, okay, rear will be pointing to index 9. Okay, and once you started popping out all the front and means DQ operation 9 times, okay, 10th time it will be pointing to 9. Okay, both front and rear will be pointing to 9. Suppose in that case, if you are trying to remove an element, means the front will become more than the size of the array. Okay, so it will cross rear. Okay, in such case, we need to reset the value to -1. Okay, whenever the front is crossing rear, okay, front value is greater than rear, it means that the queue is empty and we should reset the front and the rear value to -1. Okay, that code I have not yet added in the program. Okay, I will add that code also, and after that I'll share the program. Okay, so this is what, whenever you are the DQ operation, okay, DQ operation you are performing and the front is becoming greater than rear. Okay, at that time the queue is empty, so we should reset the front and the rear value to -1. So after that, again we can perform the addition value. Okay, and checking empty queue is empty. Okay, that part is difficult. Okay, let us take this example. Okay, now let us take this example. Here the size of the queue is a 6 element. The maximum index is 5. Okay, if I'm inserting one more index here, okay, instead of 1, after 1, if I'm inserting some 10 here, okay, now rear will be pointing to 5. Okay, and it reaches the maximum index. Suppose after this I am performing DQ operation 3 times. So 7 will be removed, 2 will be removed, 6 will be removed. Now front will be pointing to 3rd index and the rear will be pointing to 5th index. Okay, now suppose if I'm checking the queue is empty or not, the queue, it will give the queue is empty. Why means rear is already pointing to the maximum index. Okay, so we should not check whether a queue is empty or not in array implementation by comparing the rear with the maximum index alone. Okay, why means sometimes because of DQ operation, there may be some free rooms in the beginning of the array. Okay, so this will happen only in the array implementation, because in linked list implementation, each node we are creating dynamically and adding it to the linked list and deleting, freeing the memory of each node in the DQ operation. But in array implementation, it is not that case. Okay, so once we declare an array, some 10 rooms or 5 rooms memory is allocated statically. So we are simply moving the front and rear values by 1, incrementing or decrementing. So we should not check rear equal to maximum index, then overflow error. Okay, it is not correct way. We should also check the front also pointing to 0. So if front is 0 and the rear is a maximum index, then only the queue is full. Otherwise, what we need to do means we need to move all the elements from 0 to some elements. So shift all, arrange all the elements. Okay, so normally this is the difficulty in array. In array, suppose if you wish to delete an element in the middle of the array, okay, then after that whatever the elements are there, that we need to copy one location prior. Okay, so the same operation here also we need to repeat. Okay, so that is what one difficulty in queue implementation. Okay, so that concepts are not implemented in the sample program that we discussed now. Okay, so that I will discuss. That I will write in the second program. Okay, queue array implementation second program, and that program also I will share. Okay, but basically what is the front value, rear value, and how to perform this in-queue operation, DQ operation, queue front, queue rear. This is sufficient. And the important condition you should understand is whenever the front is crossing rear, it means that the queue is empty and we need to reset the front and rear to -1. Okay, Rahul, got it? Any other doubts? Okay. Now, the next concept is the application of a queue. Okay, so queue is the application of queue. Okay, so where in the queue is the queue application is in our real life. In many places, we can see the applications of queue. The one very good example of application is categorizing the data. Okay, this you can see it in many banks. Whenever you are entering into a bank, you have to get one token number. So based on the token number, there will be some different queues, and based on your request. So when you are entering into the bank, some request will be there. So regarding loan, credit cards, saving account, you have to press that particular category and get the token number, and that particular token number will be served by particular queue. Okay, so who are entering into the bank? Okay, so entering into the bank, that is one queue, main queue. Okay, then based on your request will be processed by separate queues. Suppose if you are entering into the bank to inquire regarding personal loan and vehicle loans, then queue number 1. Okay, then credit card related queries means queue number 2. Suppose saving account related means queue number 3. Suppose it is related to current account means queue number 4. Suppose if it is related to home loan means queue number 5. So initially all the persons are in the same queue. Okay, and based on your request, you will be categorized and added into different queues. Okay, so this is categorizing data. Okay, instead of a customer, so you can take any place. Suppose if you are getting some n number of data here. Okay, n number of data here. Based on its value. Okay, let us consider it as marks. Okay, suppose if the first person mark is greater than 90, then grade A. The first first queue is grade A. Then second person's second grade, and third grade, and fourth grade. So based on the grade, we can add the data into different queue and for further processing. Okay, this is another example. The same way, suppose if there are two machines are there. Okay, first machine and second machine. Okay, first machine is keep on sending some data to second machine. Okay, suppose if there is any delay in the network. Okay, the second machine needs to wait in some amount of time until it receives the data from the first machine. Instead, the second machine, what it can do means it can create a queue. Okay, so whenever the first machine sends data, all the data will be sequentially added into the queue. Okay, and later the second machine can start reading the value from the Q2. So it will be sequentially. Okay, whatever the data sent by the first machine, it will be stored in the same order in the Q1 in the queue. Okay, so the second machine can start reading from the queue and process it. Okay, so wherever we are in need of a buffer kind of things. So that places also the queues are useful. Okay, so these are some of the applications of a queue. Okay, and the queue application. So this example, okay, we can I'll show the implementation of this queue in the next class. Okay, next class we will discuss the implementation of this categorizing data queue example. Okay, and the next concept is a doubly linked list. Okay. So what is a doubly linked list means? Okay, in a general linked list, okay, each node will have one pointer that is pointing to the next element. Okay, so this is the structure that we are using. See here, linked list implementation. Here, each node, 10 is one node, 20 is another node, 30 is another node, 40 is another node. Okay, each node contains one data part and a pointer to the next node. Okay, a data part and address part. The address is address of the next node. So 10 and address of 20, 20 and address of 30, 30 and address of 40, 40 and null, because this is the last node. Okay, so this is what singly linked list. Okay, so this implementation is called as a linked list or singly linked list. Okay, normally all singly linked list is called as a linked list. Okay, because it will have single pointer to the next node. Okay, linked list or singly linked list. What is doubly linked list means? It will have two pointers. Okay, pointer, then data and a pointer. Okay, so doubly linked list will have two pointers. It will have address of the next node and also it will have address of the predecessor node. So we can traverse the list in both the directions. Suppose if it is possible to traverse from the last node to first node and also from the first node to last node. Okay, because each node in the doubly linked list will have two pointers. Okay, that is next pointer and previous pointer. The next pointer will have the address of the next element and the predecessor pointer, previous pointer will have address of the previous node. Okay, so this is what doubly linked list. Okay, so mostly the node structures will look like so a doubly linked list will look like this. Okay, so a head pointer will be pointing to the first node. Okay, and see here a 10. Okay, so for this first node there is no previous node, so the predecessor pointer is a null and its next node is a 20, and for 20 previous node is a 10 and the next node is a 30. Okay, and for 30 previous node is a 20 and there is no next node, so it's a null. Okay, so each node in the doubly linked list will have two pointers, predecessor node and next node. Okay, so this is how a doubly linked list will look like. Okay, now let us try to see the simple implementation of doubly linked list. We can convert the singly linked list implementation into doubly linked list by simply modifying the structure pointer. Okay, so the structure content. Okay, list operation 2. See here in this list operation, insert new data and display be implemented. Okay, let us perform only these. Okay, so here next pointer. So let us save it as another file. Save as doubly linked to the list. Okay. Now here instead of next pointer, let us have one more pointer called previous. Okay, next pointer and previous pointer. Okay, in create list, there is no need of any change, and in the insert node, we should have next pointer. We need to, after creating the new node, after creating the new node's data must be the parameter value, and the new node's next is null, new node's previous is null. Okay, then new node next equal to L1 head, means whatever the value pointed by the head node currently. So that node must be pointed by new node next. Okay, and head must be pointing to the new node, incrementing the count variable. Okay, display. Okay, display we can perform from front and also from the rear. Okay. Displaying from the rear. Let us do it later. First, let us check whether this is working or not. Insert 100, insert 200, insert 300, insert 400, then display. So the values are getting displayed 400, 300, 200, and 100. Okay. Now display reverse. Okay, so the implementation of this doubly linked list and its code we'll see in the next session. Okay, so if you have any doubt in today's session, you can post it in the classroom. Okay, so in next session, sir, in our implementation of queue, if we declare